Hi guys, welcome to the K nearest neighbors with Python lecture. After the theory lecture, it's time to learn by doing. Let's create a situation here. This time, you got the dataset which is highly confidential. Your client doesn't want to disclose the hidden features or dimensions in the dataset. All the features are coded with some numbers. Your client makes the decisions. Data is growing, and your client wants to automate the process. You are given a task to use the coded data along with the target class in results column and help your client in the decision making. You decide to go with KNN and create a model that predicts the target class for the new customers. This is a great choice. Let's move on and explore how to work with this dataset. Once again, we will start with the new Jupyter notebook, and the first thing first, we have to import some libraries that we are going to use in this project. Import pandas as pd, import cborn as sns, and let's import matplotlib as well. Import matplotlib.pyplot. Once again, press tab for autocomplete as plt and import numpy as np and matplotlib inline for data visualization within the Jupyter notebook. Let's run this cell so there is no error. All the libraries are imported properly. Let's read the data file. So our data frame df is equal to pd dot read underscore cs3 coded. So you have the file in the folder, press tab for autocomplete. So here we have, let's run this cell and our data frame is ready now. Let's check the head of the data frame. Run this cell and this is our data now. Notice that in our data frame, the first column looks like index. Let's set this column as an index. So let's copy this line here, paste it here, and check the head of our data frame again. So now we have set the index, which is column 0 in our dataset. Let's add few cells here and have a quick overview on the dataset. We can use info here. So df dot info. If we run this cell, we see we have 100 entries in our data. CD 1, 2, 3, 4 up to 10. We have 10 columns, and the last column is results. Let's see how the data look like in pair plot. So sns dot pair plot and pass in data frame df, and let's pass in hue equal to result, which is our target column. Here we have result, yes, no, yes, no. Let's run this cell. This pair plot could take some time. So here we have our pair plot. You may not get much information from this plot and may need to do more data visualizations using range of plotting options to learn more about the data. However, our focus is machine learning here. So we are not going to do much exploratory data analysis. Still, we see that there are two classes separated by green and blue colors, and we see separation in most of these plots. So moving forward, in the theory lecture on KNN, we have learned that the predictions are made by identifying the data points that are near to the test data point, which is majority voting based on the K value. In such situation, the scale of the features does matter. Variables with large scale will have larger effect on the distance between the observations and also on the KNN classifier as compared to the variables on smaller scales. To deal with this issue, we need to do standardization of the variables on the same scale. Scikit-learn provides a built-in feature to do this all, which is a great option. To move on with standardization using Scikit-learn, we need to import standard scalar from Scalar. Let's import standard scalar. So from Scikit-learn, and standard scalar is a part of pre-processing. Pre-processing import standard scalar. You can always press tab for autocomplete. Let's run this cell, and here we have imported the standard scalar. Now the next step is we need to create an instance for this standard scalar. So scalar equal to standard scalar and run this cell. Now we have instance scalar for standard scalar. Let's separate the features and the target now so that we can fit scalar on the features only. Our target is df result and our features are df. We can use drop here, and which column we want to drop? This result column. And what is the axis? 1. And run this cell, add few more cells and check the head of target and features. Target dot head, and here we have the target dataset. So we have yes, no, and yes in the target. And features dot head, run this cell, and this one is our features data frame. We created an instance scalar. Let's fit scalar to the features now. So scalar dot fit. This is the similar stuff what we used to do in the previous lectures, where we created an instance for linear or logistic regression, and then we used that instance to fit on our test data. So scalar dot fit, pass in features and run this cell. So now we have fitted results to the scalar object using dot transform methods in Scikit-learn to do the standardization job by centering and scaling. Let's pass the features to scalar dot transform to get the standardized features in scaled features. So our new variable here is going to be scaled features. Scaled features. And we are going to use scalar here, which is fitted on features. So scalar dot transform and pass in features and run this cell. So there's no error, the code is working. The scaled features is a NumPy array. Let's check its type just to confirm. So scaled feature, pass into type. So this is a NumPy array. Let's convert this into the pandas data frame. We can use df.columns to get the column names and pass that to data frame along with scaled features while creating the data frame. Let's grab the list of columns from our data frame in calls. So calls equal to df.columns, and let's print this list as well. So here we have the list of all the columns. So we are dealing with features only. We don't need this last results column. So we can say everything but not the last one and rerun this cell. So now we have only the feature columns here. Let's add few cells again. Now to create a data frame for scaled features, we pass in data as scaled features and columns as calls. So our scaled data frame df scaled equal to pd dot data frame, pass in data equal to scaled features and columns equal to calls, and run this cell. There is no error, the code is working. And let's check the head of our data frame again. And here we have the data frame with all the scaled features. Now we are done with scaling. Our data is ready for machine learning. To move on to the machine learning part, we use capital X for the features and Y for target. Let's stick with capital X and Y and pass in the scaled feature to capital X and target to small y. We can either use scaled features or this data frame for X. So X is equal to scale features and our Y is equal to target. And run this cell. So we need to import train test split as well from Scikit-learn dot model selection import train test split. Let's run this cell and train test split. If we press shift tab, let's save some typing. We can move down and copy this code here and paste it here, delete these dots and split it into 2 lines. Let's use the test size 0.30 and leave the random state equal to 42. We need to run this cell to do the split, and here we have the splitted data in X train, X test, Y train and Y test. So our focus is to come up with a model that can predict the class in the result for the new data point. We don't know what k number will work the best. Let's start with the k equal to 1 at the moment. To move on with knn, we need to do another import for k-neighbor classifiers. Let's import k-neighbor classifiers from Scikit-learn. So from Scikit-learn dot k-neighbor classifier is a part of neighbors. So as from Scikit-learn dot neighbors import kn neighbor classifier. So with capital K, capital N and capital C. Run this cell. Let's create a knn model instance with number of neighbors equal to 1. So knn equal to k neighbor classifier and pass in number of neighbors equal to 1 and run this cell. So we have created an instance knn now with number of neighbors equal to 1. If you remember, after creating an instance, we fit on the train data. So knn dot fit x underscore train and y underscore train. Let's run this cell, and now we have trained our model. The next step is predictions. Let's do the predictions now. So predictions equal to knn dot predict and pass in our test dataset x test. Run this cell. So now we got the predictions here. Let's add few cells and move on to the evaluation, which is another very important process in machine learning. To print classification report and confusion matrix, we have to do some imports again. So from Scikit-learn dot matrix import classification report and confusion matrix. So we can import both of them in the same line of code and run this cell. And let's print the confusion matrix and classification report. So print confusion matrix, and we need to pass in our actual values we have, which is in y test, and the predictions. Let's copy this one and paste it here. Instead of confusion matrix, we need classification report and pass in y test and predictions. Let's run this cell, and here we have our confusion matrix and the classification report. So the results doesn't look very bad. We have some false positive and false negative, and our precision is 0.93. We have used k equal to 1 only. Let's explore if we can improve the model using some better value for k. Let's apply the elbow method to find out the good value for k. We can actually iterate a range of knn models using different k values, say k equal to from 1 to 30 in this process. We will get the error rate for every k value and plot against k to find out its optimum value. We can use for loop for this purpose. So let's initialize an empty list error rate equal to this empty list and for I in range 1 to 30. So we want to test the k values from 1 to 30, and we can use simple range function here. So for I in range 1 to 30, knn equal to k neighbor classifier, our n neighbors equal to I. So whatever the value of I will be, that will be used as number of neighbors in the classifier. So after creating an instance, what we do, we fit that instance to the train dataset. So knn dot fit x train and y train. And the next step is predictions. So pred I equal to knn dot predict and pass in test dataset. So now we have predictions in pred underscore I for knn equal to I. So now the error rate is going to be the average of predictions and y underscore test if both are not equal. If they both are equal, there is no error. So error rate dot append, and we can use numpy to calculate mean between prediction I, which is pred I, when pred I is not equal to y test. Let's run this cell here. There's no error, it's working properly. So once again, let's go through these few lines of code. We are initializing an empty list error underscore rate just to get the error rate from our for loop. Then we are using for loop and iterating k value from 1 to 30. So it's actually creating instance, fitting and getting the predictions for k equal to 1 to 30. So at the end, if predictions are not equal to the observed values, we are calculating mean and appending to the empty list error rate. So let's plot the error rate versus k to see which value have the lowest error rate now. We can use plt dot plot and pass in k value using range 1 to 30 and error rate that we have calculated using for loop. Let's run this cell, and here we have k along x-axis and error rate along y-axis. We can play with some aesthetics here and pass in color equal to green and marker. We want circles and marker face color. Save blue and rerun this cell. And here we have a better looking plot where k is along x-axis and error rate is along y-axis. So from this plot, it looks like our model can be improved. The error rate is minimum for k is greater or equal to 12, and it remains minimum until k equal to 16, and then bounces back with some random numbers. So we can select the k value within this range. We can select k equal to 12 and see if the model works better than k equal to 1. Let's add few lines and create an instance again. So knn equal to kneighbor classifier, pass in n neighbors equal to 12, and knn dot fit, pass in x train and y train, and then do the predictions equal to knn dot predict and pass in x test. And let's run this cell here. So let's print the confusion matrix and classification report again. Print classification report, pass in y test and predictions, and then print confusion matrix, pass in y test and predictions. Always use tab to autocomplete, and let's run this cell here. So with k equal to 12, we see that our precision is 0.95 and our confusion matrix is different from the previous one when we had k equal to 1. Let's move up and see what is the difference now. When we had k equal to 1, we had 0.93, 0.93, 0.93, and here we have 0.95, 95, and 95. We had 8 and 12 false positive and false negative with k equal to 1. With k equal to 12, we have less wrong predictions with 6 and 8 false positives and false negatives. So our model is improved. So this exercise using elbow method to find out the optimum value of k was worth. We have improved our model. Let's go back and have a quick overview on what we did. So we started with some important imports, pandas, cbon, matplotlib, and numpy. Then we read the CSV file in dataframe df. We set the index from the dataframe column and then moved on, checked the info, did some exploratory data analysis. So variable standardization is important in KNN. And then we imported standard scalar from Scikit-learn and created its instance. We separated the target and features and then fit the instance scalar on features. After that, we got scaled features using .transform method and moved on to the machine learning. We created this data frame just to see how the data looks like. We may not need this data frame for machine learning because we have features in scaled features and target in target. Then we passed in scaled features and target to capital X and small y. And then we did the train test split here. We imported the kneighbor classifier from Scalar.neighbors and created its instance. As always, we used that instance to fit the model on trained data. So here we are training our model on the trained data. Then we did the predictions and printed the confusion matrix and classification report. Then we moved on and see if we can improve the predictions of our model. In the next block of the code, we used for loop to check the k value from 1 to 30 and plotted the error rate against k value. We see that the error rate is minimum for k is greater or equal to 12. Then we selected the k value equal to 12 and rerun our model. So we trained our model, got the predictions, printed classification report and confusion matrix. And at the end, we noticed that using elbow method, we got the optimum value of k where we can improve the results from our model. So guys, this was all about the KNN machine learning algorithm. Go through this lecture once again. Try to understand step by step. If you have any question, post it in the question answer forum. I'm always there to answer those questions and help you guys. Remember, practice is a key. Machine learning is a skill that doesn't come overnight. You need to do lots of practice. Let's move on to the next lecture where we will do the project on KNN. See you in the next lecture. Good luck.